We're constantly just swimming in information. It's raw, it's messy, it's kind of chaotic. But what if there was a tool, a language even, that was designed specifically to find the hidden meaning in all of that noise? Well, that tool is statistics. And today, we're going to pull back the curtain and see how it works. At its very heart, statistics is all about this one single question. When you see something happening in the world, maybe a stock price seems to go up every time a certain CEO tweets, how do you know if that's a real thing, a meaningful connection, or if it's just random chance? That's the exact puzzle statistics helps us solve. And that's the real challenge, right? We live in a world that is just full of variation. I mean, think about it. The weather, stock prices, even your own mood. Everything is always changing, always in flux. All that natural randomness creates this constant background noise that can make it incredibly hard to see what's actually going on. So that's the mission. That's the whole game. How do we pull a clear, meaningful signal out of all that random noise? How do we find the true pattern that's hidden inside all the chaos? Well, this is the very question statistics was born to answer. And this is where statistics steps in. You can think of it as the language of data. It's this incredibly powerful system for dealing with uncertainty, for measuring all that variation, and for spotting the patterns that really matter. Now, it doesn't give us absolute 100% certainty, nothing really can, but it gives us something almost as good, a way to measure our confidence. Section 1, Data, Noise, and Us. So, to kick things off, let's look at the basic framework that statisticians use to separate the important information from all that background static. The whole field really is split into two big jobs. First, you've got descriptive statistics. Think of this like drawing a really detailed, accurate map of the data you have right in front of you. But then you have the really exciting part, inferential statistics. This is where we get to be detectives, using little clues from a small bit of data to make a really good guess about the entire world. Section 2, Describing what we see. All right, let's start with that first branch and look at the tools we use to just describe the data we've already collected. How do we draw that map? So, the very first step is always to find the center of your data. We all know the mean. That's your classic average. But imagine this. 10 people are in a coffee shop, and then a billionaire walks in. Suddenly, the mean income shoots through the roof, but that number is totally misleading, right? That's why we have the median, the person smack in the middle, which isn't thrown off by that one crazy outlier. And the mode? That just tells you the most common value. Each one gives you a different, vital piece of the puzzle. But here's the thing. A single number, like an average, can only tell you so much. It's just not the whole story. To really, truly understand what's going on, we have to go beyond just summary numbers and actually see the shape of the data. And just look at this. Our brains are absolute pattern-matching machines. If I give you a table of numbers, it's just, it's noise. But a simple bar chart like this one, bam! The comparison between these categories is instantly, totally obvious. That's the magic of visualization. It turns raw, boring data into an insight you can understand in a split second. Section 3, Inferring what we don't. Okay, so we know how to describe the data we're holding. But now for the magic trick. How do we use that little piece of information to say something meaningful about the huge worlds we can't see? Well, the secret is something called a sample. Look, we can't possibly poll every single voter in a country, so we talk to a few hundred. We can't test a new drug on every person on Earth, so we use a small group. But here's the catch. Everything, and I mean everything, depends on this sample being good. It has to be random and representative. It has to be like a perfect tiny mirror of the whole population. So, the natural question is, if all we have is this little sample, how can we confidently test a really big idea? Like, does a new teaching method actually improve scores for all students based on what we saw in just one classroom? We do it using a formal dance called hypothesis testing. It's actually a really beautiful logical system. You start by assuming nothing interesting is going on. That's your null hypothesis. It's the boring default state. Then you say what you think is actually happening. That's your alternative. You collect your data, you figure out how surprising your result is, and then you decide, is my data surprising enough to throw out that boring default assumption? I bet you've seen this number everywhere, 95%. It pops up in polls, in scientific studies, It represents a level of confidence. But what does it actually mean to be 95% confident about something? This is where we use something called a confidence interval. Instead of giving just one single number, which is almost guaranteed to be a little bit wrong, statistics gives us a plausible range of answers. A 95% confidence interval doesn't mean there's a 95% chance the real answer is in our range. What it really means is that if we ran our experiment 100 times, our method would capture the true value 95 of those times. It's a really powerful way of being honest about our own uncertainty. Now, before we go any further, there's a huge critical warning sign we have to put up. This might be the single most important lesson in all of statistics. Just because two things happen to move together, like, say, ice cream sales and shark attacks, it absolutely does not mean one causes the other. They're correlated, sure, but a third thing, hot weather, is actually causing both. Please, always, always remember that. Section 4 statistics is everywhere. Now that we have the core ideas down, let's zoom out and just see how deeply these statistical tools are woven into, well, pretty much everything. Yeah, statistics isn't some dusty subject you take in college. It's the operational backbone of our modern world, seriously. Whether it's developing new medicines, building risk models for the stock market, or discovering new scientific truths, statistics is the fundamental toolkit that lets us make smart, data-driven decisions. And here are just a handful of real-world examples. Every single time you hear about a new drug passing clinical trials, that's hypothesis testing in action. When Netflix recommends a movie it thinks you'll love, that's statistical modeling. The very layout of most websites you use is determined by A/B testing, which is just a pure statistical experiment. And that brings us to the big one, AI. Modern artificial intelligence, when you get right down to it, is applied statistics. Machine learning is really just a fancy modern name for incredibly sophisticated statistical models that find patterns in data. The entire AI revolution that's happening right now, it's built on a foundation of statistics. So here's the bottom line. Statistics gives us a structured, powerful way to think about a deeply uncertain world. It gives us the mathematical tools we need to find that signal in the noise, to go from a bunch of random data points to actual, real understanding. It literally turns chaos into clarity. There's this quote that I think just captures it perfectly. Data, by itself, is just a pile of raw facts and numbers. Knowledge is understanding what it all means. And statistics? Statistics is the essential bridge that lets us get from one to the other. And so that leaves us with one final thought. We are absolutely drowning in data today, more than any other time in human history. With the tools of statistical thinking, you have the power to analyze it, to question it, and to pull real meaning from it. The only question left is, what will you choose to understand?